Now we're in homework for the problem 1. This problem needs us to find and draw the distribution function of y and the density function of y in terms of distribution function and density function of x. So we have the equation of y equals gx, and this is the equation, and also we have the picture of density function of x. Okay, so in this condition, at first, in order to better understand the y's, we need to draw the picture of y. So like this. So from this picture, we know that y is between -1 and 2. So from this, we know that the density function of y with this function with the condition that y is less than -1 and y larger than 2 is 0 and 1. So we got this. So now we need to find in this interval, we need to find the distribution function of y and the density function of y. So so we need to divide it. We need to consider different case. So when y is equal to -1, we got the probability that y equals to -1 is this, and it's very easy to get. So we got this 1 minus the distribution function of x when x equals to 2. Okay, so we got this. And also in the next case, we consider y no less than -1 and less than 0. So in this case, we know that x is no less than 1 and no more than 2. In this case, we got this. So it's just it's just the equation like before, and we got this. Okay, so now in the next case, y equals to 0, and we use the same way to get this, and also when y equals to 2, and we got this. Okay, we have these 4 cases, and also so with these 4 cases, with these 4 cases, we got the density function of y when y equals to -1. So we got this. So it's actually the impulse response, and we got this. And when y is less than 0 and no less than -1, we have this. So we got this. Because it's not actual values, exact values. So actually it is an impulse response. So the result is this. And also when y equals to 0, we got this. It is still it is an impulse response. And also when y equals to 2, we got this, and otherwise it's 0. So we got the density function of y, and we can draw this picture from this this equation, and also we can get this from the density function of the picture of the density function of x. From this, we can get the picture of distribution function of x. It is the same. It's according to the definition. So we got this picture, and finally we need to get the distribution of distribution function of y. So we have known that when y is less than -1 and y is more than 2 is 0 and 1. So we need to calculate this. Okay, from this, we know that when y is no more than 0 and no less than -1 is like this. So so actually we know that we have got this. So we know that in this interval the distribution function of f of y is just it's just the distribution. It's just like this, and we use the we just need to transmit this to this. So we got this. And also when y is less than 2, we know that we have known that when y is in this interval, x in this interval, we have this. So it's just just transmit this. We got this. So that's the whole thing of the distribution function of y, and according to this we can draw the picture of the distribution function of y, and it's like this. So that's the whole things of the problem 1.